Good morning, students. We'll today discuss about molecular orbital theory, which is a very important topic for school examinations as well as for the students who are preparing for medical entrance examination. This topic is from class +1 chemical bonding. Atomic orbitals or molecular orbitals. First, ये है क्या चीज है? Atomic orbitals are those orbitals in which electrons are present in atoms. So atomic orbitals are related with atoms. ठीक है, examples जैसे 1s, 2s, 3s, 2p, etc. These are atomic orbitals. वो जो फिल करते थे 1s2, 2s2, 3s2, etc. 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 Those are atomic orbitals. Now, when atoms combine, suppose one hydrogen atoms combines with another hydrogen atom to form H2 molecules. See, there is one electron in this hydrogen atom. Similarly, one electron in this hydrogen atom present in its atomic orbital, 1s. In this case, in H2 molecule, the two electrons are present in orbitals. Now, these orbitals, in case of molecules, are known as molecular orbitals. Okay, so this term is related with molecule. Am I clear? Atomic orbitals are those orbitals which are occupied by the electrons of atoms. Similarly, molecular orbitals are those orbitals which are occupied by the electrons belonging to molecules. Here AO stands for atomic orbital and MO stands for molecular orbital. For example, let one atomic orbital overlaps with another atomic orbital of second atom. Two molecular orbitals are formed. Out of these two molecular orbitals, one is known as bonding molecular orbital and another is known as anti-bonding molecular orbitals. Okay? मैं दोबारा repeat कर रहा हूँ. If two atomic orbitals combines, then two molecular orbitals will be formed. Out of these two, one is bonding, another is anti-bonding molecular orbital, represented by sigma pi for bonding molecular orbital and sigma star pi star for anti-bonding molecular orbitals. Now, sigma or pi क्या है? This symbol sigma and pi is for type of bond formation. See how sigma bond is formed. When atomic orbitals overlap with one another around internuclear axis, जिसे बोलते हैं head-on collision, the result is sigma bond. Okay, कुछ examples लिखिए. Sigma bond is formed by s orbital overlapping. If both the atomic orbitals are of type s, then bond formed as sigma bond. Okay. Similarly, s pz overlapping results in formation of a sigma bond. Okay. But when atomic orbitals overlap at an angle perpendicular 90 degree to the internuclear axis, क्या बोलते हैं हाँ, lateral overlapping results in formation of a pi bond. When px orbitals overlap, that results in formation of a pi bond. Similarly, when py orbitals overlap, that results in formation of a pi bond. Okay, यहाँ पे कुछ इसकी प्रॉपर्टीज हैं. बॉन्डिंग और molecular orbitals are of lower energy and therefore more stable. Bonding molecular orbitals actually represents bond formation. Anti-bonding molecular orbitals are of higher energy and are less stable in comparison to bonding molecular orbitals. Okay, this axis represents energy. Suppose an element has three subshells, 1s, 2s and 2p. इसकी कुछ एनर्जी लेवल मॉलिक्यूलर ऑर्बिटल डायग्राम बनाई हुई है यहाँ पे. इससे देखो है क्या चीज है. when 1s overlaps with 1s orbital of second atom, that results in s overlapping. यहाँ पे देखो sigma bond. Two types of molecular orbitals will be formed. नाम क्या होंगे उनके मैंने? sigma 1s bonding molecular orbital and sigma star 1s. First one is bonding molecular orbital, second is anti-bonding molecular orbital. Okay, sigma जो without star लिखा है, that bonding molecular orbital, another with star is anti-bonding molecular orbital. Okay, jump to next. 2s. 2s orbital belonging to one atom overlaps with 2s orbital belonging to second atom. It will result in formation of two molecular orbitals. क्या नाम होंगे इनके? sigma 2s, sigma for ss overlap. 2 कहाँ से आया? second subshell. sigma 2s and sigma star 2s. Okay. Similarly, next subshell is 2p. Now 2p subshell has three degenerate orbitals, 2px, 2py and 2pz. We are considering z as internuclear axis, main axis basically. So pz overlapping will result in formation of sigma bond as shown there. py. अच्छा एक चीज ध्यान रखनी पड़ेगी यहाँ पे. px will always overlap with px of another atom. Similarly, py orbital of one atom will overlap with py orbital of another atom. So px check करो px क्या फॉर्म करेगा? It will result in formation of a pi bond. नाम क्या हो जाएगा इसका? Its name is pi 2px. Let me make one orbital. Okay. Next is py. It will overlap with another py. Name pi 2py. Okay, the point to remember here is that pi 2px and pi 2py are found to be of equal energy. Same. Next is pz. This. It will form third bonding molecular orbital. नाम क्या होगा इसका? sigma 2pz. Okay, scientists, these are bonding molecular ऑर्बिटल्स। क्लियर? नेक्स्ट देखो, अगर 3 बॉन्डिंग मॉलिक्यूलर ऑर्बिटल्स फॉर्म हो रहे हैं, इट मींस 3 एंटी बॉन्डिंग मॉलिक्यूलर ऑर्बिटल्स भी फॉर्म होंगे, सो दैट टोटल नंबर ऑफ मॉलिक्यूलर ऑर्बिटल्स फॉर्म्ड remains equal to total number of atomic orbitals combined. चेक कर लो कितने थे यहाँ पे atomic orbitals, 1 2 3 4 5 6। ये molecular orbitals फॉर्म कितने हुए हैं, 1 2 3, so 3 left again। इसके एंटी बॉन्डिंग क्या हो जाएगा, पाई स्टार 2p x pi star 2p y। Third one is sigma star 2p z। देखो, is it clear? For simplicity से मैं यहाँ पे इंक्रीजिंग ऑर्डर ऑफ एनर्जी लिख रहा हूं, इंक्रीजिंग ऑर्डर ऑफ एनर्जी ऑफ वेरियस molecular orbitals. First is, try करोगे, first one is साथ साथ बोल रहे हैं, sigma 1s, then sigma star 1s, then sigma 2s, sigma star 2s, pi 2px equal to pi 2py less than sigma 2pz, pi star 2px equal to pi star 2py, last one is sigma star 2pz। सी ऑर्डर में लिखे हैं, ठीक है, बट मोस्ट इंपॉर्टेंट पॉइंट इज दिस ऑर्डर इज वैलिड अप टू नाइट्रोजन, not beyond nitrogen। Okay, मैं सेकेंड लाइन लिख रहा हूं, इंक्रीजिंग ऑर्डर ऑफ एनर्जी ऑफ वेरियस molecular orbitals for oxygen onwards। Oxygen onwards, it follows this order: sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz। Let me write this with different color. This is the only change. Sigma 2pz। Rest of the order is same as above. Pi 2px equal to pi 2py, then pi star 2px, pi star 2py is then sigma star 2pz. On diagram change क्या हो जाएगा बेटे? ऑक्सीजन ऑनवर्ड्स, यहां पे आ जाएगा सिग्मा 2pz and one step above pi 2px and pi 2py. ऑर्डर्स नोट करो दोनों up to. From molecular orbital theory we can write the electronic configuration, we can find the bond order, and also we can predict the magnetic character of a particular molecule or an ion. Electronic configuration, we have two orders. First is up to N2, second is O2 onwards. Up to N2 it is sigma 1s, as I have already written earlier, sigma star 1s, sigma 2s, sigma star 2s, pi 2px, pi 2py, sigma 2pz, pi star 2px, pi star 2py, sigma star 2pz. For this it is same. Is the difference is sigma 2pz before pi 2px and pi 2py. Rest of the order is also identical. This is the first point which one can find from molecular orbital theory. Second is bond order. Bond order is the number of bonds present between any two atoms. Bond order can be calculated mathematically as bond order equal to NB minus NA divided by 2, where NA is number of electrons present in BMO and NB is number of electrons present in ABMO. Oh, sorry. Then opposite. NB is the number of electrons present in bonding molecular orbitals like sigma 1s, sigma 2s, pi 2px. Means all the orbitals जिनपे स्टार नहीं है, ठीक है? And anti-bonding molecular orbitals कौन से हैं? With star. Okay. Third is we can predict the magnetic characteristic. Okay. Magnetic character is of two types: diamagnetic and paramagnetic. But a diamagnetic species are those species which contains zero unpaired electrons. Okay, all electrons are paired. And paramagnetic species are those which contains one or more unpaired electron. Okay. So these 3 points that we can derive or predict from molecular orbital theory. Okay. Example देखो. Consider this molecule N2. Write the total electrons. Total electrons in nitrogen molecule 14 N2. First is its electronic configuration. 14 electrons fill करो बेटे. Sigma 1s 2. As you know, an orbital can maximum accommodate 2 electrons. Sigma 1s2, then sigma star 1s2, sigma 2s2, sigma star 2s2, 2, 4, 6, 8 8 हो गए. Next pi 2px 2, pi 2p y2, sigma 2p z2. काउंट करो 14 हो गए पूरे. Yes, this is the electronic configuration of N2. Second is bond order. Bond order is number of bonding electrons. काउंट करें. Number of bonding electrons कितने हैं इसमें? 2, 4, 6, 8 and 10. 10 bonding electrons minus anti-bonding was star वाले 2, 4 minus 4 divided by 2, 6 upon 2, 3. So bond order in N2 molecule is 3. Third is its magnetic character. Check करो बेटे whether all the electrons are paired or not. All paired, pairs में ये सारे. So it is of type diamagnetic. You can find the bond order from writing electronic configuration, or there is a trick. Trick क्या है? एक कॉलम में लिखना आपने sum of electrons. These total electrons कितने हैं? Total electrons in the given species. Second column is bond order. ठीक है? Total electrons start हो जाओ बेटे. Minimum electrons possible होंगे 1, 2, 3, 4, 5, 6, 7, 8. पहले 8 electrons तक करते हैं. चलो 9 और 10 भी consider कर लो. Bond order is for 1 electron it's 0.5, 1, 0.5, 0, 0.5, 1, 0.5, 0, 0.5, 1. ठीक है. सो ध्यान से देखो ये 1 के अराउंड है. मैक्सिमम इज 1. इलेक्ट्रॉन इंक्रीज करोगे क्या हो जाएगा 1 से 0.5, देन डिक्रीजेस टू 0, again 0.5, 1, 0.5, 0, 0.5 and 1. This thing is valid till electrons 10. सेकेंड है इसके आगे चाहिए टोटल इलेक्ट्रॉन्स एंड बॉन्ड ऑर्डर। टोटल इलेक्ट्रॉन्स हैं, इसे स्टार्ट करते हैं 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 से स्टार्ट करते हैं बेटे पहले 14 से। वैल्यू है बॉन्ड ऑर्डर की 14, अभी सॉल्व भी किया था इसी लेक्चर में, क्या थी वो 3। ओके, अगर इलेक्ट्रॉन्स 13 है इट विल बी 2.5, 12 2.0, 1.5 1। सिमिलरली साइड भी डिक्रीज करना है 2.5 2 1.5 1 0.5 0। 10 से पीछे भी जाओगे 9 0.5 8 0। तो सिर्फ इसका याद रखना मैक्सिमम बॉन्ड ऑर्डर पॉसिबल इज 3। एक और चीज है, कैन ऑल्सो प्रेडिक्ट मैग्नेटिक करेक्टर। वन थिंग इज फॉर श्योर दैट इफ नंबर ऑफ इलेक्ट्रॉन्स आर ऑड देन इट विल बी पैरामैग्नेटिक। ऑब्वियसली पेयर तो हो नहीं सकते अगर ऑड नंबर है, तो पहले ऑड वाले लिखो सारे, क्या बन गया वो पैरामैग्नेटिक। P फॉर पैरा, पैरामैग्नेटिक 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 पैरामैग्नेटिक। दिस वन इज नॉट एप्लीकेबल, बॉन्ड ऑर्डर 0 है, स्पीशीज ही एग्जिस्ट नहीं करेगी। अब आ जाओ डायमैग्नेटिक पे। डायमैग्नेटिक इज this 12 18। there is one exception, even though in this case, in case of oxygen, number of electrons are 16, even number, but it is paramagnetic with 2 unpaired electrons। Okay students, याद रखना इसे, स्पेशली जो स्टूडेंट मेडिकल एंट्रेंस के लिए प्रिपेयर कर रहे हैं, वेरी इंपॉर्टेंट टॉपिक। थैंक यू, दैट्स इट फॉर द टॉपिक।